Hello, this is my second example in the elimination method series of videos. And pause the video for a second and see whether you can tell me what the difference is between this example and the example in the other video. Okay, hopefully you did that. And here's what is the difference. It's not the fact that these two things are 21 here, but it's the fact that there is no whole number that I can multiply this equation by to get the same variables here, and there's no whole number I can multiply this equation by to get the same variables here. So in fact, we have to come up with two new equivalent equations. So I'm going to call this 1 and call this 2. Now, it's just a matter of deciding which one you want to eliminate. Now, just to make it different from last video, I'm going to eliminate the b variable, but I could have just as easily have chosen the a variable. And we're going to use lowest common multiple, I suppose, in order to work out what to multiply each of the equations by. In this instance, it's pretty straightforward. For if I multiply 1 by 3, and multiply 2 by 4, I get the following equations. 3 times 3 is equal to 9a. 3 times 4 is equal to 12b. And 21 times 3 is equal to 21, 42, 63. For equation 2, 4 times 5 is 20a, plus 4 times 3 is 12b, and 21 times 4 is 84. There we go. So that's equation 3, and that's equation 4. Now, I can look ahead a little bit. Oh, sorry, before I say that, now we've got equivalent or the same terms for equation 3 and equation 4. So when I subtract the equations together, it will eliminate the b variable, leaving me with a and 63 and 84 there. So that's fine. Now, you could just subtract them like we've been doing, and that's probably what I would do. But it's probably also worth pointing out that you can probably just cheat a little bit. And if you look ahead, you can sort of see that I'm going to, if I subtract 20 from 9, I'm going to get a negative number, and that's fine. But if you want to, you could go backwards and you could subtract 3 from 4 by going brackets here and a minus, and then going that way to go 20 minus 9 and 84 minus 63. I won't do that, but I'm just saying you could do it. Okay, so 9 minus 20 is negative 11. Okay, like so. And 63 minus 84 is equal to negative 21. Okay, so then I'm going to divide both sides by 11, and I'm going to get 21 over 11. It's a fraction, but it's fine. We can deal with that. Now I'm going to take the value for a, and I'm going to substitute it into one of the equations. So I'm going to go substitute a equals 21 over 11 into equation 1. So I'm going to have 3 multiplied by 21 over 11 plus 4b is equal to 21. So that's going to give me 3 times 21, which is 21, 42, 63. So I'm going to have 63 over 11 plus 4b is equal to 21. I'm now going to subtract 63 over 11 from both sides. So that's going to be 4b on that side. And, well, I'm going to have to probably work out what 21 is as 11ths. So I'm just going to, I've got my calculator here, and I'm going 21 times 11, which is equal to 231. And then I'm going to take 63 away from it, and I get 168. That's 168 over 11. And then if I divide both sides by 4, I get 168 over 44. So those are my two fractions. I should simplify that fraction, but I won't do it in this video just to keep it short. But you could simplify the fraction, and then you're good to go. Another good step would be to then substitute these two values into the second one to make sure you get the same value. And if you don't, then check it out again. Your graphics display calculator is really good for solving those kinds of things. Okay, I'll leave it there.